streaming here. But this is definitely the time in the semester when the assignments start to get, I don't want to say more difficult. It's just the first few assignments is just like you just change some numbers and, you know, it's just basically, can you just write some code? But now I'm actually, okay, now we're actually getting into some basic problem solving. 4 and 5 are like this. And then once we get into the last few assignments, it gets even more difficult. So there's really 3 phases, I think, of the semester. We're kind of entering the second phase. And then the last few assignments, that's when people really tend to have the most difficulty. So you got to keep up with it. If you thought, you know, oh, the first few assignments were just so easy, I don't have to really do any work in this class. I think I try to give a gentle introduction to this class and not just throw everything at you all at once. Because a lot of people do have difficulty with programming, but I don't want you to think that means that's how it's going to be the whole semester. I just try to ease you into it, okay? Does anybody have any specific questions regarding assignment 4? Yeah.
How do I input the different shipping rates?
Okay, so what I would say is go back to these choice-based programs that we did, like with assignment number 3, where we'd have something like well, okay, so what I would do is you make a menu-based program, so it'd be like, and then fill out the rest. Okay, choices 2 and 3. And then remember we did these programs where we'd have a choice and then, is this familiar to everyone now? And then you'd have some if statements if choice was 1, if choice is 2. So what you'll do is there's really 2 parts to the program. The first part is just calculating the base shipping cost based on the weight. The whole second half of the program, and I think that this is where people get confused, is they try to mix the 2 parts. Treat them as essentially 2 entire sections of the program. One is that you get the base cost. The second is where you calculate the, where we take into account the shipping speed. A couple of notes. I flipped through a few assignments. It's okay to use a string, but I would say the preference is just to use this choice because it's kind of hard to mess up pressing 1, 2, or 3. Somebody might misspell something. They might use capitalization or lowercase. I tend to like these numeric menu-based choices because it's hard for the user to enter in something incorrectly. So treat them as 2 halves of the program. And then also remember, I always see people introducing a bunch of variables. For some reason, and I saw this the other day, I see people make 3 variables. A variable for slow, medium, and fast. You don't need, and then my first question is, okay, well, what do you do with those variables? And a lot of times people just create the variables just to create variables. Think it through. What is this variable for? Really, there's only 1 variable to hold the user's choice, and then you have to decide which choice they made. Okay, if you have 3 variables, that doesn't really help you. You just got 3 variables just sitting there doing nothing. You want 1 variable called choice, just like we've done with the menu-based programs in the past. Okay, so it's essentially just taking 2 different techniques, one where we're doing range-based programs with if statements to see if it's between 2 values, and then the other is these menu-based programs where we have a choice. The very last thing is that you don't actually, previously we had a variable called price. What I'll often see people do is things like this, like introduce a new variable called price2, something like that. You can actually just reuse that variable. The way it's looked at is that we say, okay, price, so we calculate some price, and then we can say, okay, the new price is equal to the old price times 1.1. Does that make sense? The way this is evaluated is that it evaluates everything on the right-hand side of the equal sign. It takes the original base price, say it came out to $30. It takes that $30 multiplied by 1.1, gets an answer, and then stores it over here. Now, I won't take off points if you introduce new variables, but it's not really necessary. I think you only need 3 variables. You just need the double weight, the the double for price, and then int choice. You can solve this program reasonably with just 3 variables. Okay. Any other questions? Okay. And like I said, I'll send out announcements for some help. I don't want to burn through too much class time here, so let's get right into today's examples. Any questions on anything before we get started? Okay. One more other quick thing. I have noticed that it was a little concerning between 2 classes. Very few people, 2 sections, so this and another section. Now I've noticed that attendance in here is pretty good. But if you're having difficulty with the assignment, one of the first things I would suggest is just rewatch the lecture. Find out exactly where you were lost or where you didn't quite understand it. And don't be afraid to retype out those code examples and pause, slow it down. YouTube has all kinds of tools for slowing down the lecture to half speed if you need to. Okay? Turn on captions if you need to, if it's if like you want to be able to pause it and see what I was saying at the time. Okay. Okay, so no questions on anything? Everyone's, just to say one more time, everyone's clear that I've extended this due date a couple days, but I'm not going to extend it again. This is pretty much it, because we have to keep on moving through the semester. We're assignment number 4. We'll get to about 8 assignments at the end of the semester, but that's misleading because I can't give you the last assignment on the last day of class, you know? So realistically, the last assignment I've got to give you on like week 14. That way, by the time you hit your final exam, I've already had that assignment graded, and we've done, you know, I've given you the answer, and you know how to go through all that and stuff. So realistically, this is kind of really the real halfway point of the semester as far as assignments go. Okay, so let's get right into code examples. So let's start up a new. Okay, I'm streaming here without any problems. Everything is good. I'm going to start making these fonts slightly smaller. I'll turn out the lights in the front so you can at least see a little bit better. This might be a little bit too small. Let me go one more. Just because it gets to the point where at first the fonts have to be very large because you're dealing with a lot of new things. But it gets to the point where the programs start to get a little bit longer. You can only see a small part of the program. So I have to shrink the fonts a little bit to be able to see, you know, more of the program. As much as I can do without making the room super dark. But that font size is still large enough everyone can see, correct, in the back and everything? Okay. So we're going to just go to a whole new topic. Usually I like to do some review, but because I'm recording these lectures and we're kind of reduced on our time, I don't want to do, you can always rewatch the old lectures. So we covered if statements. So let's kind of go through our overview of what we've done so far in the course. So we started off writing code where the code just runs from top to bottom, left to right. Okay, just like you'd read a book. And then we said, okay, well that works. But then we introduced these things called if statements, conditional statements, where we said, okay, if a certain condition is false, I can skip over that code. So basically, if some condition is true, only when it's true do I actually run that code. And we came up with ifs and then else and if, else, if, and all these different ways to do that. But essentially, our code was still running top to bottom, left to right. and just every once in a while we would skip code or run certain code under certain conditions. We're going to do something a little bit different now, is that oftentimes you want to actually repeat code over and over again. And the only way to do that so far in this course is that if we had just copied and pasted the code. If we wanted to run a piece of code 3 times, we'd have to copy and paste the code 3 times. But we have these two different things called, they're called loops. We have these two different types of loops. We have while loops and for loops. In my opinion, it's a little bit easier to explain while loops. So we'll do that. In practice, I've noticed, I don't know, this is very non-scientific, but I do tend to notice that we use for loops more often. But they're a little bit more complicated, so we'll start off with the easier type. Okay. So let's do this. Let's say int I. And just as a quick note, at this point in the course, we would always declare a variable and then assign it separately. I think we've done enough in this class that we can understand that, and I do that very purposefully to understand that there's two phases. I declare a variable, I tell the compiler and the operating system that I need some memory for this variable, and then I assign it. As a shortcut, we can actually just do this all in one step. So I'm going to start doing that in a lot of these examples just to save a line of code, is that we can just initialize and assign just in one single step. Okay, everyone's clear what's happening? It literally just took those 2 lines of code and combined it into one. Now the way a while loop works, it says while some condition is true, run the code between the curly braces. So while something is true, well, what's that something? In this case, I'm going to say while I is less than 5. So by the way, don't run this code until I tell you, because it can cause issues, to say the least. Okay. It's very possible if you run it too early, it might lock up your browser. Okay, so I say int I is equal to 0 while I is less than 5. I'm going to say cout I and L. And so what's happening here is I've set I is equal to 0. We've already seen these inside of if statements. They work the same way. They have to evaluate to either true or false. 0 less than 5. That's true. If it's true, it's going to run the code between these curly braces. Now, in this case, I only have the 1 line of code, but we could have 50 lines of code. We could have if statements inside of here if we want. Any code that we've worked through so far, we can put inside of these curly braces. Now, don't run yours. I'm going to run mine, and it's very possible it might lock up the browser. So I'm going to copy this, and I may have to restart my browser, but let's see. Okay, that's good enough. What happened here? It printed 0 a bunch of times. Just pretty much forever. And I caught it before it locked up the browser. Why did it do that? Why do you think it just kept on printing 0?
Because I is less than 5.
Exactly. It just kept on saying, is 0 less than 5? Okay. Is 0 less than 5? Print this. Is 0 less than 5? It just kept on doing that. We created what's called an infinite loop. Infinite loops are useful sometimes, but for the most part, they're kind of limited in their usefulness. They have very specialized time to use them. Most of the time, we don't really want an infinite loop. So what we have to do is we have to make progress towards some goal, because we don't want to just loop forever. We want to loop some number of times. Eventually, the goal is to eventually make this false. Eventually, we want to stop going through this while loop. So it's very common is to modify. So in this case, if I wanted this to be false, okay, it just needs to, if I could eventually get to where I is equal to 5, 5 is less than 5, that's false. It's equal to 5, but it's not less than 5. So it would say 5 less than 5, false, and then the while loop would be done. The most common way to do that is just simple counting. So what I'd say is I is equal to I plus 1. And then now, you can go ahead and run it now. It's okay to run. We get 0, 1, 2, 3, 4. The last time through, it printed 4. So type it, run it, and then let me step through it with you. So the first time through, I is 0. And by the way, there's a reason that we start with 0. It'll make sense later in the course. But right now, for the most of the time when we're counting, we count from 0. It really won't make sense until we get to arrays why we do this. So we say 0 less than 5. Okay, so we print 0. And then we say 0 plus 1 is 1. We store it over here. Is 1 less than 5? That's still true. We print 1. And then we have 1 plus 1 is equal to 2. And then we store that 2 over an I. Next time through, we say, is 2 less than 5? It's still true. We print it. We say, okay, 2 plus 1 is equal to 3. And then we store it over here. Go through the next one a little bit faster. 3 plus 1 is 4. And then the last time through, this prints 4. And it's going to say 4 plus 1 is 5. It's going to store it over here. And it's going to say, is 5 less than 5? That's false. And then it jumps out here. And we can just so we see what's going on here, we can write so notice that it keeps on looping through here until we hit 5 less than 5. And then it jumps out of this loop to line number 12, and it starts just going through the code normally again. Yes?
Is it better to write it out I equals I plus 1, or is it just as good or better to use like I plus plus?
So that's good. I do a lot of things where I wave my hands and I'm kind of secretive about things. In practice, we almost always use I++. The reason I don't like to use that, and for those that don't know what that is, we'll get to that in a little while. The reason I don't like to do that initially is I really like to give everyone a sense of what's going on, is that we're taking the stuff over here and then storing it back over here. But in practice, you almost always use I++.
Okay.
So if you already understand this and you know how this works and you use I++, you're welcome to use that on assignments and stuff.
Okay.
And probably by the next couple of weeks, we'll probably just move over to I++ for pretty much all of our stuff. Okay, so that's a while loop. That gives you the basic sense of this idea of it repeating things over and over and over again. Let's do this. So let's do a more involved example with while loops. And for this example, we're going to also use string. So let's include string. So what we're going to do is we're going to make a program that only lets you into the program if you guess a password. So let's be part of a larger program. It's going to be password protected. Now I'll tell you ahead of time, don't actually do this for password protecting programs. somebody could look at the output assembly of it and guess the password. So don't do this in real life, but for a class example, this is okay. Okay, so we're gonna have we're gonna hard code the password. We'll just say the password COP2000, and then what's gonna happen is the user is gonna guess the password. But rather than just guessing once and the program failing, we're just gonna keep on asking them for the password over and over again until they guess the correct password. So already it sort of implies that we're going to use a while loop because we're just going to keep on asking them until they get the correct password. Then they can start the main program. Okay. So we're going to have a string, and we'll call it, so this is going to be the real password. And again, remember, mentally think that we're having assignment and declaration as separate steps, but this is just a quicker way. So we'll say COP2000. And then string user password. And right now we'll just make it an empty thing. So the real password is the password they're trying to guess, and then the user password is whatever the user is providing. Maybe we could have called it input password, but I've already typed it, so. And so we know, because I already told you, that we're going to need some sort of while loop. And the basic idea is that we want to know if the two passwords are equal. If they're equal, we'll let them through. So we'll say that if the real password. Now, what I could do is something like this. Real password is equal to user password. But there are times where we actually want the opposite. We want the complement. We need to use the not equals. Okay, so here, knowing that the two passwords are equal, I don't really care about that. What I want to know is if they've entered in a bad password. I want to know if they're not equal. And so to do that, remember we very briefly talked about that, but I think this is the first code example we'll have. To check that something is not equal, we use the exclamation point equal. And it's saying if the real password is not equal to the password that they provided, then let's give them a little error message that says, not even so much an error message, it just says, please enter password. And have them enter the password. It may just be easier to read. Okay. So while the two passwords aren't equal, it's going to keep on asking me. So let's do this. Let's add some cout statements here. So while they're not equal, they're just going to keep on, it's going to get stuck in this loop forever. There's no way for me to accidentally break out of this loop as long as the two passwords don't match. So let's go ahead and run this. So let's test it a few times. So it seems like it works, but let's make sure that the logic is correct, because that's always very important. So once we're in this over and over, let me think how to phrase this. Once we're inside of the loop, we can see that it's going to keep on asking for the password over and over, because they enter in a password. It says, okay, is hello equal to COP2000? No. Ask for the password again. What happens the very first time we run the program? What happens the first time through? What's it comparing it against? It's going to say, is COP2000 equal to... We haven't entered in a password yet, so what's it comparing it to? Sort of. Restate that. So you said nothing. Think about another way to say that. So what did we set it to initially? Just an empty string. There's nothing in it. So the first time through, what it's actually saying is saying, okay, while, so don't type this, COP2000 is not equal to this blank string right here. Well, of course they're not equal. So you always have to think things through like that. The first time through, it's gonna, because we've given it a good default value, this is gonna work correctly. Because the first time through, of course it's not gonna be valid because it's just an empty string. And then from there, it keeps on looping through. And now we have to think, is there any way to get to line number 16 without the passwords matching? No, just fundamentally how the logic is. This is going to keep on looping through until the passwords match. As long as they don't match, this will just loop forever. There's not some weird test case or something that we could do to make this, as long as the two aren't equal, as long as they haven't guessed the correct password, this is just going to keep on going in a loop. Okay. So does everyone feel comfortable with while loops? Now this is a use of while loops, but in practice, I don't even know what it's asking for this time. Stairs. Did I miss any? Yeah. If it just gave me access to the, there we go, okay. I'm just going to copy paste reload like we did before. I've noticed that when you lose Wi-Fi with it, that I don't know what happens, it doesn't work quite right after that. In practice, a very common thing, so this is an example of while loops. While some condition is happening or not happening, just keep on looping through. But this very first example that we had here, this is actually very common, that we just are counting up to some number, and as long as we're counting up to that number and we haven't reached that number yet, keep on executing some code. We're going to learn about these things later called arrays. It's very common. Arrays are sort of like variables, but imagine if you could group variables together into, like, say, rather than an individual student, I could have a group of students, and then each one would have a grade. I want to be able to go through those grades one at a time with a loop. So it'll make sense later once we get to arrays. But just for now, know that this pattern of wanting to count one number at a time is extremely, extremely common. It's actually so common that there's a shorthand version for the while loop called a for loop. And it's much more compact and condensed. And the first time you see it, you might think, how is this easier? But it's just one of those things. If you do an activity that, is super, super common, a lot of times they'll just come up with a nice syntax for it to make it a little bit more compact and make it less error prone. Okay, so that's what we'll go through now is the for loop. So the basic structure of a for loop, it's very similar to a while loop. We use the word for, and then we've got some stuff here, and we're going to keep on repeating over and over again. It's broken up into 3 parts. Now, if we go back to this first example with the while loop, we actually see those 3 parts. It's not super clear, but we see them. The first part is what's called the initialization phase. What we have to do is we have to do something once. Notice that is this line of code in the while loop, or is it outside of the while loop? Line number 7.
Outside.
It's outside. So how many times is this running? Line number 7.
Once.
Just once. So that's the first thing that we do. So we can say int I is equal to 0. And then now it's going to seem kind of strange, but we actually put a semicolon in here. You'll see why in a little while. So the first part is our initialization, and it only happens once. It's just our setup phase. We also see here the while loop part. So while some condition is true, keep on looping through. So in this case, it was while I is less than 5. So that's the next part. This is our while loop part. While I is less than 5, keep on running the code in the curly braces. Finally, we had one more part, is that, remember, without this, what happened? We ended up with our infinite loop. This ran forever. So we have to make progress towards some goal. We have to do something at the end of each iteration of the loop. And that's what this last part is that we have to, this is kind of like our post after all of our regular code is run. We have to eventually make progress towards some goal. So this happens at the end of each iteration of the loop. And so that's what we put right here. We'd say I is equal to I plus 1. Eventually we want to make this, in this case we want to make it 5. We go 0, 1, 2, 3, 4, 5. So this initializes I and it sets it to 0. This checks, this is basically our while loop. It says while I is less than 5, run the code in here. So let's do that. We'll just say cout I. And then after each iteration of the loop, once we're done, we do this. We say, okay, I is equal to I plus 1, and then it goes back in here and checks. It says, okay, is I still less than 5? If it is, it runs the code, then runs this thing. And so you kind of see it's just like runs over and over and over again, except for this one part here, this initialization, this setup, this only happens once. Okay, so everyone's good with the basic structure? And let's do this. Rather than 5, let's do 3. So we run it, and it should give us 0, 1, 2. So I already mentioned it's very common to use these loops, especially for loops with arrays, which we haven't gone over yet. But let me give you another example of when you might want to do something over and over again. If I wanted to find the average of 3 numbers, how do I do that? I add up all 3 numbers and then divide by 3, correct?
Yes.
Now, let's say, for example, these are my 3 numbers. 5, 3, and let's do 5, 3, and 1. So what I could do is I could say, okay, 5 plus 2 is going to be 7. Actually, let's do this. We'll do 5, 3, 1. Just to make the math line up nicely, that's all. So the first time through, I do 5 plus 3, which is 8. And then the next time through, I do 8 plus 1. From our rules of algebra, I can do this, correct? It doesn't really matter the way I add these together. So it turns out I can do this with a for loop, is that I can say each time through, take the numbers, add them together, store it somewhere. So in this case, 5 plus 3, store that result, and then the next time through, take that result, and then add the next thing to it. Now, one quick thing is, okay, this works, but what do we do the first time through? Also remember from our rules of algebra, can I do this? Is this valid?
Yes.
Yeah, because what is it? It has no effect, correct? It just gives us back, I can't remember which property this is, but 0 plus 5 is just going to be 5. So I can do that. So the first time through, I want it to be 0 plus 5, which is 5. Then it's going to be 5 plus 3, which is 8. And then 8 plus 1, which is 9. And let's just worry about the adding numbers up part right now. Let's not worry too much about because at the end, all we have to do is once we get the total, we just divide it by 3. So that part's pretty straightforward. So I hope I'm not confusing anybody. I just have 3 numbers here, 5, 3, and 1. If I want to add them all together inside of a loop, what I could do is I could just put a bunch of code and then just hard code it. But that's not super useful because what if I have 50 numbers? Okay. So what we do is we keep on asking users for numbers. In this case, the user is going to give us 3 numbers, 5, 3, and 1. So what I can do is the first time through, notice that I'm kind of implying that we're going to use a loop. The first time through, I could say 0 plus 5, which is going to give me 5. I take that total, add 3 to that total, which is the new total is 8. And then I take the last number, 1, and add it to that total. And eventually we just end up with 9. So let's start to do that. So we're going to have a double called total, which is going to be our running total. We're not going to calculate all the numbers at once. We're going to calculate them in pieces. Oops, and we'll just call it, double total is equal to 0.0. And then each time through the loop, I'll just comment this out for right now. Each time through the loop, I want to ask the user for a number. So it's going to be interactive. We're not going to hard code all those numbers because we don't really have a nice way to store them yet. So it sort of implies that I need a temporary area as I'm getting these numbers. I don't know all the numbers at once. I'm asking the user for them one at a time. Okay, so let's introduce another variable here. We'll just call it number. And so we can do this. We can say, okay, enter number, and then store that here. And we shouldn't write too much of our program without testing. So let's just test that this works. So what numbers did we say? 5, 3, and 1, I think. So I enter in 5, 3, 1. Perfect. I wanted to loop through this 3 times, and that's what happened. The first, so it initialized it to 0. It said, okay, is 0 less than 3? That's true. It ran the code. At the end, it said, okay, 0 plus 1 is 1. Store that over here. It said, okay, is 1 less than 3? And it keeps on going through all until the last time through. It said 2 plus 1 is 3. It stored it over here. It says, okay, while 3 is less than 3. Well, that's false, and then it ended. Okay, does everyone see why that? By the way, we don't use less than or equal, just it's common to use less than. We'll see this again. A lot of this stuff has to do with arrays, which we haven't learned just yet. But this is the most common form. You might think it would make sense to start counting at 1 and go up to including 3. We just, it's for something that we'll learn later. This is the most common structure that you'll see. Okay, so that works. Now we can run what's called an accumulator. We can accumulate values. So we can say, okay, this total is going to equal the old total plus whatever number the user just gave me. So this code is going to run 3 times. And so 3 times we're going to ask the user for a number. And then each time through, we're going to say, take the old total, add it to whatever number they just gave me, and then store it over here inside of this new total. Does that make sense to everyone? Remember that it always runs the stuff on the right-hand side first, gets an answer, and then stores it over here. The first time through, so we've already agreed that we walked through that this is going to run 3 times, correct? We already tested it and we saw that. So it's going to run 3 times. It's going to go 0, 1, 2. In this case, we actually don't care what I is. It just kind of gives us a good way to track how many times we run through. But there are times where we will want I. The first time through, what is total? We've already seen it from here.
0.
0. So it does 0 plus 5, which is 5, stores it over here. The next time through, it's going to be what's total this time through.
5.
5 plus 3 is 8, and it stores it over here. The last time through, what is total?
8.
8 plus 1 is 9, and it stores it over here. And that's the third time through. So it says, it runs this, and it says, okay, we're done with the for loop. And we can see out total is. Okay, everyone saw how that, do you need me to step through it again, or everyone has a good idea of how that works? Okay, and by the way, you don't have a new assignment this week, so you will have a little bit of time to look over this. I still want you to concentrate on the other assignment, but make sure that, because I will give you a new assignment next week, bless you, make sure that you understand for loops and while loops, because we will do an assignment soon. Okay, so we got the total, but that really wasn't the problem that we were trying to solve. What was the problem that we were trying to solve? Finding the average, which is... Let's introduce a new variable to do this. So let's say underneath total, let's say average. And then so the average is going to just be the total divided by, in this case, 3. Everyone's good so far? So we didn't really do much. The goal wasn't to find the total. The total was just like a problem that we had to solve along the way. And once we had the total, very easy. We just said the total divided by 3. And that's the average. Now here's the issue that we run into. If I wanted to, instead of asking for 3 numbers, I wanted to ask for 4. So let's do that. So if I change this to 4, so don't change your code because we're gonna make a revision in a second. That doesn't seem right, right? Which should be the average should be 5, but we got a different number. Why is that? I'm saying total divided by 3, but how many numbers did I actually input? 4. Okay, so I have to change it in 2 spots. Again, don't type this because we're going to do something better. Now, we fixed it, but hopefully you can see how error prone that is. Anytime you find yourself having to change the code in multiple spots, and again, code is like it's a living thing. You don't just write code and that once and then that's the end of it. It's very common that you write it and then people want modifications or you get new requirements. Stuff happens over time. You might not even be working there anymore. It could be somebody else. So you generally don't want to put yourself in a situation where you've got to change to make a minor modification. You've got to change it in multiple spots because, as you can already see, if you say, okay, I'll just change it to 4, and it's very subtle because had we just put in a bunch of random numbers, you'd be like, it kind of looks like it's calculating the average. That's good enough. So let's do this instead. So we can introduce an int and call it count. And notice I'm using all caps here. That's for a reason. Is equal to 4. So what we could do is just replace this, which is good. Because now if I wanted to change it to 5, how many places would I have to change it?
1.
Just in one spot, it's way less error prone. Now, and let's just run that to make sure it works. Don't want to go through too much without testing. Perfect, so that works. Now, kind of as a side note, the language actually has some safety features built in. You don't have to necessarily use them, but it's a good idea. What if, now this is a very short program, and don't write this because I'm gonna get rid of it. This is a very short program, but what if somebody, it's a 1,000-line program, and then somewhere in the middle somebody thought, oh, okay, I'm just gonna change this to, and then I go ahead and run it. It gets the incorrect average. If there's a value that we know is not going to change and we want it to be the same no matter what, there's actually an additional special keyword. Const. Exactly. Now, if I were to try to change this, it's not even going to compile. It's going to say, hey, which is short for constant, meaning unchanging. Hey, you declared this const. You didn't mean to change this. Often you is another programmer, or you in 6 months. And so we're going to start to use this anytime we have to use these in for loops or anything like this. We're going to start to introduce constants. Now, remember I on some of your assignments I said don't use capital letters for variables. This is the reason, is because when you use capital letters, you generally are saying that, hey, I'm using a constant. Other people will look at your code and they'll see a capital letter and they'll think, oh, they were writing a const. But you weren't. And so you'll end up with people very upset at you because for that reason. So like on a Celsius and Fahrenheit, you'd use capital C's and F's. That's the reason, is because I read that, I see a capital C or capital F. You must mean that you're dealing with some sort of constant. But it was just a plain regular variable. So going back to naming, plain old regular variables, we just do in all lowercase. If they're all caps like this, it means it's a constant. And there are certain other things that we won't really learn in this class where sometimes we'll capitalize just the first letter, but I don't really want to get into that. But just know for right now, our naming convention is two things. It's a regular variable is all lowercase, and if it's one of these constants that we can't change, we do in all caps. And again, this is just a convention from working at many places over the years that pretty much everybody follows, but you may end up working somewhere where they don't follow this convention. Google does something weird. They actually, if you're ever curious about these naming conventions, Google puts a document out there. We don't really have time to get into it, but they put a K in front of all their constants. I don't know, but so it's not strict that everybody follows it. Some places do it a little bit different, but this is generally the way you do things. Now, finally, as a quick thing, we've already seen that we can initialize things to 0. Does anybody remember the shipping example? Or no, I'm sorry, not the shipping, the gravel, when we had an invalid price and it said price is and then some crazy number? That's because when we start the program, whatever random bits happen to be in that place that we happen to declare this variable, that's what you get. That's generally not what we want. So from now on, let's just get in the habit of just giving everything a reasonable default. So let's just 0 out everything. Makes life a little bit simpler. The reason that it doesn't do it automatically was because the original C language was created a very long time ago, and for performance reasons, initializing things and zeroing them out could cause a performance impact. But for the most part, the stuff we're doing, computers are so fast it doesn't really matter. That little tiny, very, very tiny fraction of a second, it's okay for the extra safety. Okay, so let's just run this one more time, but now let's change this to 5, and let's make sure that it calculates correctly. Perfect. Okay, I know we did a lot in that example. Study this example because you don't have a specific assignment on it this week, but next week I will assign something, and then we're just going to get right into it. This was a little bit involved, but I think it really shows a lot of things all at once, so I think this is a good example. Any questions on this or anything that doesn't quite make sense? Now, later in the class, we will see that there's a shorthand version for this, but for right now, if you know what the shorthand is, you can use it. But I like everyone to know what's going on here is that we're taking the old value of I, adding 1, and then storing it over here. But this is such a common thing, we actually have some shorthands for that as well. Okay, so that's it for loops right now. Normally, I don't introduce 2 topics in one day, but we're going to be using these for the next few weeks, and so I'm going to actually introduce 2 things at once. And that's why you don't have a new assignment today, is because I don't want to, I'm already giving you enough new topics. Okay, so and then we only have 2 more examples to get through today in 15 minutes, so we should be good. So now I'm going to talk about a topic called functions. And I'm guessing most people in here, I'm just going to assume most people or everyone, I know some of you might know it from other classes you've taken, but, and these functions don't really have anything to do with functions in math, okay? There's some similarities, but in general, no. When you're writing very small programs like we've written so far in this course, we don't really have to worry about organization that much because I'm thinking maybe the longest program we've written in here is maybe like 40 or 50 lines. It's been pretty small. It's very, very easy to stay organized when you're just dealing with 50 lines of code. Imagine if you're dealing with 50,000 lines of code, or 500,000 or 5 million lines of code. Then organization becomes actually the main thing you're concerned about. There's actually entire topics of how to keep your code organized. Most people can actually learn the syntax and how to write basic programs fairly quickly. After maybe a couple, 2 or 3 courses, most people have enough to start writing some pretty useful programs. The problem is that over time, you're not the only programmer. You have to work with other people. You just flat out need it organized. You want to break things up into little chunks. There may be stuff that you don't understand. There could be something very complex. Like say, for example, you buy some sort of robot or like a drone. You're not a mechanical or electrical engineer, and you want to operate this thing. You don't want to have to know the low-level details of how to check for battery usage. Is it going to actually be able to get to its destination? How to leveling algorithms, all the different concerns. But you might want to just do a very simple drone that just kind of does laps around a track or something like that, which is relatively simple. But there's a lot of low-level details that maybe only an electrical engineer or some sort of other engineer would know how to do. So people get very frustrated at this point in the course because they're like, I know how to write the program without these organizational techniques, but that's not the point, because in the real world, we don't have programs that are like this, like we've been writing so far, where you just open it up in a REPL and it's 50,000 lines of code. That's not how it works, okay? We have to break it up into small chunks that are reusable. So let's write a piece of code. I'm not going to explain what it is just yet. I'll explain it after we've written it, okay? Now note that I'm writing this outside of main. Okay, I'll explain why in a minute, but just for your own purposes, when you're typing this out, make sure you're putting it in the correct spot. So this thing right here is called a function. I like to think of a function as like sort of like a box, okay? And inside of that box is some code. You might have written the code. Somebody else might have written the code. Doesn't really matter. There's just some code inside. That's what this stuff is here. On one end of the box, you feed it input. So in this case, we've got a function. It's a very simple function. You wouldn't actually write a function like this in the real world. This is just because you just do the 2 numbers added together. This is just more to show you the structure. So I've got this box where I put in 2 numbers, and then on the other side it spits out an answer. Those 2 numbers added together. How it arrives at that, we actually don't care. Now if we're the ones actually making the box, we do have to care. But if we're just using that box, we don't have to care. But in this case, we're the one designing it, so we do care a little bit. So we have to give it a name. Here we're calling it, and it should be descriptive, add 2 numbers with underscores in between. Remember our naming convention, we could use the underscores. Now, the stuff in the parentheses here, remember I said that you give it values, you feed stuff into the box? That's what this is that we declare variables, and that becomes the input to the box. Now, the general structure is if it's, and I called them A and B, but I could have just as easily called them X and Y or num1, num2. Okay, just like in previous examples, we try to come up with good names like total, average, and number. We kind of want to do the same thing here. These are just plain old variables inside of this. If we're going to have 0, which I don't think we'll have time today, but you just do this as empty. If you just have 1 input, you just do it like that, and then 2 or more, you just comma separate them, and so on. Okay, but we're just going to have two inputs here. And then we kind of need to know what's going to be returned. In this case, it's going to be an integer. So this is just saying, hey, this is the type of thing to expect outside of the when you get a result from this box, this function. Okay, and then on the inside, so this is defining the function. This is sort of like maybe like you can think of it almost like a blueprint. And then here's the stuff inside of the box. We're going to declare a new integer result. We're going to say result is a plus b. Where did a plus b come from? Right here. This is what the user is going to give us. Okay, we don't have to know values just yet. We just know that they're going to give us two integers, a plus b. And then finally, this special keyword return. Notice that this is blue. This is what's going to be returned on the other side, the output of the box. So we take in the inputs, integer a and integer b, and out the other side we give this result a and b as integers, and we use this special keyword. So that's defining a function. Now to actually use a function, to call it within main, we would say add to numbers, and let's add 2 and 3. So this is how you call a function. And a and b, well, we're just going to pass it the values 2 and 3. When we run it, nothing interesting happened. Why? Remember, it returns something out the other end. We kind of ignored that, but let's store that and let's do something with it. So we'll say int total is equal to whatever this returned, and then we can see out total is total. So this seems like a really simple, kind of almost useless function. But imagine going back to our drone example. Imagine if you had a function that said, go to GPS coordinates. And they had some sort of API of some sort. And you called this function, go to coordinates. And the drone was smart enough to get to a height where it knows it could get to it without crashing into any trees. It checked its battery levels. It was able to stabilize, and it knew the correct speed. It knew how to correct based on if the wind was shifting it over. A lot of interesting things would happen, but you don't care about any of that. You just want it to get to its GPS coordinates. Okay? And so they would write a function with all those concerns handled in here for you, and then in the end, in your code, you would just call go to coordinates. Okay. Now, even in the case where it's not something super complicated, it's very common that you just want to make something reusable. So a good example of that might be if you, so there's nothing built in to the language, like to be able to square numbers. You have to actually call an external function. That's very simple. To square a number, you just take, I could just write a function right now, just int num1, num2, and then just do, I'm sorry, it would just be num1, it would just do num1 times num1. But I might want to make a function for that just because it makes my code more organized. So there are times where there are very complicated things you want handled for you, but a lot of the time it's just makes the code much more readable. Okay. Now we only have a couple minutes left, but I do want to touch on one thing. We've actually been using one function this entire time. What do you think that function is? Now that you see what a function is, that we've written a second function, what do you think the one function that we've used for every single program starting back at the original day one of the course? Main. Main is actually a special function. It's called the entry point of the program. And it follows everything that we just talked about. It has a return value, a return type, a name. Now it's a very special name. It has to be called main because the compiler looks and it says, okay, you made a function called main. This is where I start. Every time you run the program, and because you're not really passing the program any arguments, because the program's just starting up, we have this blank thing right here. And we've always been returning 0, but you can actually return different values on whether your program successfully exited or not. We've been kind of lazy about it and just always return 0, but various operating systems have return codes that you can say, if the file wasn't found, return this number for file not found, okay? So we've actually already been using functions. I think that's pretty much all we have time for today. Any questions on anything? So the quick things. No new assignment this week, but really make sure to study up on these 2 things, functions and loops, because we're going to be using those a lot the rest of the semester. And I just wanted to give you a week to just kind of digest all this. Make sure that you're working on this other assignment number 4. I did give a 2-day extension, and I'll be sending out an announcement about how to get some help on this assignment. I'm thinking that Friday is going to be the day that I can offer some help. And it's not going to be live help, it's going to be online, but just watch out for the announcements. And I think that's it. No questions? Okay, all right, everybody stay safe, and I'll see everybody next week, or possibly for